Hi everyone, welcome to this new series on understanding data science and pre-processing, especially for data science and machine learning and deep learning projects. In the world of data science and machine learning, having a good understanding of data is one of the first steps. So before we dive into complex machine learning algorithm, understanding the structure, quality, and the patterns in the data is very, very essential. And in order to do this, we will apply a few exploratory data analysis techniques to uncover the insights and detect anomalies in the data or identify potential problems and challenges with the data, namely noise and outliers and extreme values, and so on and so forth. So pre-processing involves typically handling missing values, addressing outliers, or scaling the features for optimal machine learning performance. It's like preparing the canvas before painting, sort of like that. So let's get started. Before we get into the actual topic, there are some of the prerequisites for understanding the pre-processing would be understanding a bit of Python, and NumPy, Pandas, and SciPy and visualization techniques, and basic and elementary statistics and mathematics would be handy. Some pre-processing steps might involve a little bit of machine learning techniques as well, especially for the advanced topics. So let's discuss the background behind the data and pre-processing. Typically, the types of data that we handle in AI would be numeric data, text data, image data, and time series data. For this particular video series, I'm going to be focusing on techniques which are applicable to numeric data. And while we talk about natural language processing or computer vision or some advanced machine learning, I will cover the necessary pre-processing and data understanding techniques and steps for those data types as well. So the topics I've divided into multiple, categories. So initially we'll be talking about the data and feature types and tabular form, and subsequently I will be covering each of the major topics. So about data and data table, and why are we calling this as a data table? Because in AI and machine learning or data science, the data has to be presented in the form of a table. That means we should have rows and column structure. And in the context of machine learning, a data table is also known as data set or data matrix or structured arrangement of data. So what is the meaning of structured arrangement of data? Typically rows and column. And rows will be observations or instances or like a record. And the columns would be, the attributes or features or variables associated with that instance. So data table is a fundamental building block. Let's take an example here. So this is an example of people data set and age, gender, height, and weight. These are attributes, and each of the row is an instance or observation. And the class is also essential in the context of machine learning. So you could divide the data, or you can say this particular person belongs to class of A, depending on the characteristics of the data here. We will talk more about the class and categories and the labels in the subsequent slide. Now, in terms of names, so the rows are called record, and the records are also having various other synonyms like samples, point, case, entities, instance, entry, or objects, or data points, or document, tuple, transactions, and feature vector. These are all different acronyms or synonyms for the same thing. Similarly, the columns are also called by various synonyms like attributes, variables, field, and predictors and characteristics. Why do we have so many different synonyms for the same thing? Essentially, data science is a field of combination study, and it has evolved in the last 60 to 70 years by the team of mathematicians, the team of statisticians, team from information theory, and so on and so forth. And in every different engineering field, the terminologies are slightly different. So just a quick understanding of feature in terms of independent and dependent variable. So in machine learning, whenever we have columns, for example, here we were talking about the columns like age, gender, height, and weight. These are independent columns, and the class that you have, which is basically label, and that would be a dependent column. So let's set that context very clear, because we will be using this term independent variable. Sometimes it's called predictor also. Predictor meaning the column which help in defining a label or help in predictions. Dependent variables, which are sometimes also called outcome or a label or target response. Let's take an example here, dependent variable. Let's say the text test mark by students, and that would be dependent, and independent variable would be the amount of time the student is studying, or the IQ score, and so on and so forth. Those would be independent variables. So let's look at some examples here. For example, this is a temperatures data set, and you have independent columns like month, day, week, temperature 2 days before, temperature 1 day before, and average temperature for the last 1 month or 7 days or whatever. Similarly, the temperature forecast by other agencies and forecast by your friend could be independent column, and all of these together can help predict or define temperature for a particular day. So this column in blue would be a dependent variable. Let's look at another example here. This is about no loan application, and again, lots of columns here. And the column loan amount can be possibly the column that you can use to predict, and that can be your dependent column, and the others can be independent column. Now, choice of dependent and independent column is dependent on the task that you're trying to solve, and also requires significant domain knowledge. Let's talk about one more case. This is automobiles data, and here you have the column cylinders, displacement, horsepower, weight, and acceleration, and year and origin, and the model name, which is in text form. Um, since we are going to be focusing only on numeric data, so we are not going to talk about the text data here. Now, using these columns, we might be able to predict how many kilometers the car would actually run. So this would become independent column. Sorry, that would become your dependent column, and the others are your independent column. So one more example of diabetes related data set, and again here the columns like number of pregnancies and glucose level, blood pressure, skin thickness, these are all independent column, whereas we have the outcome column, whether the patient is diabetic or not, that would be a dependent column. Now in data science and machine learning, The independent columns are typically represented like x1, x2, x3, x4, and so on and so forth. And the dependent column is y. And the reason we do so is we are saying y is a summation of or a function of x1, x2, x3, and so on and so forth. And that's the convention we follow in all the AI projects. Similarly, cancer-related data set, again, the cancer stage can be dependent column and the others can be independent column. Likewise, you have to frame the data in machine learning with dependent column and independent column. So this is interesting here with the month and the number of jobs filled in that particular month. So what would be dependent and independent? You can pause the video and think about it. Yeah, so essentially here, the number of jobs that you have, this column, this is essentially the column that you're predicting. So this is Y. So this prediction can be based on the last or previous three variables. So then these three would be your predictor columns or independent columns. Similarly, this one can be Y, can be dependent on the last three values. So those three values would be your X1, X2, X3. And this kind of data is typically called time series data, where a particular value is dependent on last few values. We're not going to talk about time series data in this particular video series. Likewise, you could also have text data, which is, for example, let's say, a particular text, and that text is neutral, and some of the text is, positive sentiment. Let's say this is, review given by users and reviews given by the user. So some of the reviews are positive, negative, and all that. So this column is Y or dependent, and these are my independent. Now, when we talk about natural language processing or text processing, I will be talking about how do we extract each of the word, and then each of the word becomes the column or x0, x1, x2, x3, x 500,000. Quite common in text to have so many columns. So let's talk about the feature types now. There are different types of features. Let's go through each one of them. Numerical features, quite easy. Age, temperature, height, and income. Those are numerical features. Categorical features are something which has to do with the categories. For example, district code, region code, product code, or product category, or zone or country. These are examples of your categorical features. Textual features are simply the text data, document, sentences, paragraph, or PDF, and so on and so forth. Date and time features, which are temporal in nature, which indicates date and time information. And likewise, you have Boolean features which can take values like 0 and 1 or true and false, like, um, the product quality good, yes or no. Product pass the quality test, yes or no, right? Or gender, male or female, right? So those are Boolean features here. Geospatial features are also very important in data science. These are to do with the projects which are based on based on the spatial nature, for example, longitude and latitude. Similarly, we have data types like images and videos, which are for typically like computer vision tasks, and the audio data is another type of data that we deal with. in AI, especially speech recognition or music analysis or pattern recognition within the audio signals. Derived features are features which are to do with additional feature that we build or take out of the existing features. So let's talk about some of the examples of numerical features. So first type is continuous numerical variables. So they can take infinite possible values within a given range. Example would be height, 1.71, 1.79, 1.61, and so on and so forth. Temperature 31, 31.1, 31.2, and so on and so forth. And that's why it's called continuous numerical variable. The other type is called discrete numerical variables. Here we have specific values that the variable can take. Let's say number of children, number of siblings, number of cars, number of parks, or number of defects, number of visitors coming to your website per hour. So those are values called discrete numerical variables. It's very essential to understand the difference between the type of data that we have in our data set so we can plan the model selection and the processing style and the steps. Some more categorization of numerical variables. One type is called ratio variable. So what is ratio variable? Any time a variable which has values and that has a true zero means something which is like absolute zero. For example, height, weight, and income. They have true zero values, and they are called ratio variables. Most of the time, we deal with the ratio variable. So about 90 to 90% time, we will be dealing with the ratio variables. Then we have interval type of variables, which are essentially which do not have a true zero. That means let's talk about temperature in Celsius. Temperature in Celsius, 0 degree is not an absolute value because you have Kelvin scale as well, right? So in that case, we have a different zero. So we have to consider those factors as well. Moving on to discrete variables. Again, a type of numerical variable, we talked about it, something which is very discrete or countable, you can count. That's called discrete numerical variable. And there are gaps. There could be gaps here. For example, number of students in a classroom, 31, 37, 47. So there could be, gaps in the value. The number of cars in the parking lot, again, these are examples of discrete variables. Why we are talking about all this? It's essential to understand the type of data that we have in order to choose a proper machine learning model, let's say, neural net or logistic regression or, decision trees, is really absolutely important to understand the nature of data that we deal with, so we choose the right model down the line. So categorical variables are essentially qualitative in nature, and they represent some categories. And I gave some examples of categories, for example, region code, product code, or the colors. Let's say red, amber, green. Type of fruit like sweet, sour, or long fruit, yellow fruit, red fruit. These are examples of categorical variables. It's very important again to understand categorical variables. It's not easy to deal with categorical variables when it comes to machine learning or neural nets. Another example would be payment method, credit card, cash, and PayPal methods. So So those that defines your categorical variable. Ordinal variable is another type of categorical variable, essentially something which has meaningful and logical order, but you will not have exact magnitude of difference between the categories. So we'll take an example again. So this is going to be non-uniform intervals between the categories. You can do a little bit of arithmetic operation, but not not all of the mathematical operations will be applicable or valid here. Let's see some examples of ordinal variables. Education level, like high school, associate, bachelor's, master's, PhD. So you can see these are having logical order, but the difference between the categories is not uniform. That means the distance between the high school and associate need not be same as the distance between bachelor's and master's. It's very important to understand this distinction. This affects machine learning in a significant way. So socioeconomic status, let's say low, medium, high. Again, it has logical order, but does not have any uniform magnitude of difference. The nominal variable, which is again a type of discrete variable, or you can say it's categorical variable, but this time you will not have any order or any inherent order within the categories. So no non-uniform intervals now. And absolutely no arithmetic operations really make much of a sense here. And again, the examples are type of fruits, let's say apple, banana, orange, completely random data and nothing to do with any kind of order here. Countries, let's say, all these country names, these are examples of nominal variables. Now, again, the discrete variables, ordinal variables, nominal variables are um, are challenges when it comes to machine learning. And there are techniques that we have to consider when we face such data in our data set. Binary is a column where you have dichotomous values like 0 and 1, only two categories, gender like male, female, or true, false, and so on and so forth. So examples are gender, smoker, yes or no, voter, voted, did not vote, married, married or not married, right? So those are examples of binary. It's slightly easier, situation to deal with the binary variables, but not so with the nominal variables and other discrete variables that we talked about. So you can test your understanding so far. You can pause the video and take a look at these examples. Okay, so that's it in this particular video. In the next video, I'll be talking about essentially the pre-processing steps, um, and I'll walk you through each of the steps. See you in the next session.